So, what's the invisible force that's basically running our entire digital world? Well, behind almost every single app you use, there's a special language that brings order to absolute chaos. Today, we're going to pull back the curtain on that language, SQL, and the databases that it commands.
I mean, seriously, think about it for a second. Every post, every single user profile, where does all of that information actually go? And how in the world does an app find your specific data among millions of other people in like a split second? You've got the giants, right? Google, Amazon, Instagram. These companies are built on one thing: data. We're talking an unimaginable amount of it every single day. For them, managing all this information isn't just a part of their business, it is their business.
And that really gets to the heart of the problem. Without some kind of system, all that information is just digital noise, a complete mess. So the big question is, how do you organize that digital chaos?
While the answer, and really the hero of our story today, is the database. This is the elegant, superstructured solution that takes this flood of data and turns it into a perfectly organized, manageable library of information.
So what even is a database? At its core, it's pretty simple. It's just a collection of data. But the real magic is in how it's stored. It's kept in a format that makes everything easy to get to and easy to manage. Just think of it like the world's most efficient digital filing cabinet. You know, a perfect way to picture this is an old-school teacher's register. It's got those neat columns, right? Roll number, name, marks. Each row is just one student. A database does the exact same thing, just on a scale that is absolutely mind-blowing.
Now, databases really come in two main flavors. You've got your non-relational ones, which are a bit more free-form. But today, we're zeroing in on the other kind, the relational database. This is the world of neat tables with clean rows and columns, and it's the kind that speaks the language we're about to dive into, SQL. Okay, so you've got this amazingly organized database. But how do you actually talk to it? You can't just type in plain English, "Hey, go find this user's profile for me." No, you need a very specific language, a set of commands that it understands. And you don't even talk to the database directly. You have to go through a kind of translator. Here's how that whole chain of command works. You, the user, never touch the data directly. Instead, you talk to a piece of software called a DBMS. That stands for Database Management System. Think of it as a gatekeeper, or a super efficient librarian. You give your command to the DBMS, and it does all the heavy lifting of fetching or changing the data in the actual database.
And that special language we use to speak to the DBMS? That's SQL. It stands for Structured Query Language, and it is the universal way to talk to and manage data in these relational databases. Anytime we want to create, read, update, or delete information, we do it by writing a command in SQL.
All right, let's zoom in a bit and look at the most fundamental building block of a relational database. It's the table. This is where all the real magic of organization happens.
So here's a super simple example, a student table. You can see the structure right away, can't you? We've got these very specific columns for a student's ID, their name, and their marks. It's clean, it's logical, and it just makes sense.
So here's the really crucial thing to get. The columns are what define the design of the table. In the database world, we call this the schema. It's the blueprint. The rows, on the other hand, while they hold the actual data. Each row is one unique record, in this case, one specific student. All right, that's enough theory. Let's see what this language actually looks and feels like. We're going to build and then talk to our student table using some real-deal SQL commands.
You know, pretty much everything you could ever want to do in SQL boils down to one of these four basic operations. It's often called CRUD: create, read, update, and delete. For this quick explainer, we're going to focus on the first two, how we create our data and then how we read it back. First up, we have to create our table. This command is us defining that blueprint, that schema we talked about. We're telling the database, hey, create table student, and then we lay out the rules for the columns. We specify that the ID is an int, that's an integer, a whole number, and the name is a varchar, which is just fancy speak for text. Marks is an integer too. This structure is what makes sure our data stays perfectly clean and organized. And boom, there's the result. The command runs, and we get this perfectly structured but totally empty table. It's basically a container, all set up and just waiting for us to put some data inside.
So let's put something in it. For that, we use the insert into command. What we're doing here is telling the database to add a brand new row into our student table with these specific values: 101 for the ID, Quran for the name, and 88 for the marks.
And just like that, there it is. Our very first record is now officially in the database. Our empty table has come to life. See? We've gone from an empty blueprint to storing actual useful information.
Okay, so the data's in there. How do we get it back out? How do we even look at it? For that, we use the select command. That little star, the asterisk, is just a shortcut that means all columns. So this command basically translates to show me all the columns from the student table.
And this is exactly what the database gives us back. It shows us the data we asked for. Honestly, this is probably the most common command in all of SQL. It's how we ask questions or query the database to get the information we need. We turn all that stored data back into real answers.
So let's zoom back out. These simple, logical commands, create, insert, select, this is what's happening under the hood every single time you use an app, visit a website, or do pretty much anything online. SQL is the quiet, powerful engine that keeps our entire digital lives organized.
At the end of the day, that's what it's all about. It's the ultimate tool for asking questions of data and getting answers. So I'll just leave you with this thought. If you had access to a massive database and now you knew the language to talk to it, what's the first thing you'd want to find out?